warm good evening to you all. Today we will be discussing about week 7 NBTL lectures. So, I shall share my screen now. Is my screen visible?
Yes, ma'am.
Okay. Today we are going to discuss about the week 7 NBTL lectures. We shall be discussing a few problems, a few objective type questions along with some numericals. So at first, let me give you a brief introduction on what we have learned in week 7. Uh, so is my screen visible now?
Yes, ma'am.
Okay, sorry for the interference. In week 7, the mainly the discussion topic was about the anaerobic treatment of wastewater. So you would have learned about the anaerobic degradation of organic matter. What are the different steps or processes involved in it? Then there was a discussion about what are the factors that affect the anaerobic process. Then you would have learned about different anaerobic reactor setups. You'd have learned about the low rate or standard rate processes and the high rate anaerobic processes. So all these were discussed in week 7. I hope all of you have seen the lecture videos. If not, please go through it and please do the assignment. The assignment is due for today or tomorrow, I guess. Tomorrow, I guess. So please do it. And today we will be discussing a few questions which are formulated based on the previous year assignment questions. So let us move on to the questions. So the first question is, during anaerobic treatment, organic carbon is largely converted to option A carbon dioxide, option B sewage sludge, option C methane and carbon dioxide, option D acetate. So any answer, anyone? Any lead, anyone?
Option B, madam. Sewage sludge.
Sewage sludge. Okay. Uh, any other answer? Anyone?
Option C, ma'am.
Option C, methane and carbon dioxide. Okay. So let us see the answer. The answer is option C. Very good. It is methane and carbon dioxide. So as you have learned, anaerobic treatment means the organic matter is converted by the anaerobic microbes in the absence of oxygen. So in the absence of oxygen, this organic matter is largely converted to mainly methane plus CO2 plus biomass. But as you would have learned about the difference between the aerobic treatment and anaerobic treatment. So in the aerobic treatment, the production of sludge, sewage sludge, some of you have said sewage sludge. So in the aerobic treatment, the sewage sludge production is more compared to anaerobic treatment. So the major advantage of anaerobic treatment is that the sewage sludge production is minimal or less compared to the aerobic treatment system. So that is one of the advantage. So that you would have learned about, like, or read somewhere about the difficulties in treating or handling the sewage sludge. So one of the major advantage of anaerobic treatment system is the minimal production of sewage sludge. So our question is, the organic carbon is largely converted to, so it is largely converted to methane and carbon dioxide. Hence option C is the correct answer, methane and carbon dioxide. So I hope it is clear for you now. Is there any doubt? So I guess there is no doubt. So let us move on to the next question. So next question is, which of the following pollutant is not removed by anaerobic treatment? Option A, sulfide. Option B, ammonia. Option C, pathogen. Option D, all the above. So any lead?
Option C, ma'am.
Option C, pathogen. Okay. Any other answer, anyone? Let us see the answer. And the answer is option option D, all the above. Some of you have said option C, pathogen. That is correct, because to some extent sulfide and ammonia will be removed in the anaerobic treatment. That actually depends upon the type of microbes present in the system. But largely, since the sulfide and ammonia, since they are in the reduced state, they will tend to remain the reduced state itself, and the removal efficiency will be very less, or the removal will be very less. So the option D, all the above, is the correct answer. For ammonia treatment and sulfide removal, for ammonia removal and sulfide removal, we do not opt for anaerobic treatment. Hence the answer is option D, all the above. So any doubt, anyone? As there is no doubt, let us move on to the next question. So option D is the correct answer for this question. So let us see the next question. So the next question is, which of the following is a positive attribute of anaerobic treatment? Option A, high nutrient consumption. Option B, simplicity of the process methodology. Option C, lower sludge production. Option D, high land requirement. So any answer?
C.
C, lower sludge production. Okay. Any other answer, anyone? The question is positive attribute of anaerobic treatment.
C, madam.
C. Okay.
C and D.
C and D. Okay. So let us see the answer. The answer is option C, lower sludge production. So let us see the options one by one. Option A says that the anaerobic treatment demands high nutrient consumption, which is wrong, because in the anaerobic treatment, one of the advantage of anaerobic treatment is the low nutrient requirement or low nutrient consumption. Then option B says that simplicity of the process methodology, which is also wrong, because anaerobic treatment demands high level of process methodology, like high skilled labor or high skilled expertise is needed for carrying out the anaerobic for carrying out the anaerobic treatment methods. So option B is also incorrect. Then option C is lower sludge production. As we have discussed before, one of the major advantage of anaerobic treatment is the low production of sludge or low production of biomass. So this is the correct answer. Option C is the correct answer. And option D says that anaerobic treatment requires high land requirement, which is wrong, because the various anaerobic treatment methods like UASB reactors, flow anaerobic sludge blanket reactors, these type of reactors are mainly we are using because it requires very low or very less land is needed for installation and operation of these type of anaerobic treatment systems. So compared to the aerobic systems, anaerobic treatment requires less land. So option D is also incorrect. So option C is the correct answer. Any doubt? Any doubt?
No, ma'am.
Okay. So let us see the next question. So the next question is, during anaerobic degradation, acidogenesis phase is followed by A, fermentation, B, methanogenesis, option C, acetogenesis, option D, hydrolysis.
Option C.
Option C. Okay. Any other answer? So this question is regarding
Hydrolysis.
Hydrolysis, okay. This question is based on what different stages or different phases of organic matter degradation in the anaerobic process. So, any other answer, anyone? Any other answer? Let us see the answer. So acetogenesis, option C is the correct answer. Let us see the detailed solution. So this I have taken from your lecture notes. So it says it shows different stages or phases of processes happening in the anaerobic degradation of organic matter. So the first stage is hydrolysis, in which the complex molecules or complex structure is broken down with the action of bacteria into smaller monomers or oligomers, or say sugars, amino acids and peptides. So that stage is known as hydrolysis, which is phase 1. Then comes the phase 2, which is acidogenesis. In acidogenesis, the smaller molecules, they are getting converted to the short chain volatile organic acids with the help of this fermentative bacteria. So that is stage 2, and it is known as acidogenesis. So our question is, after acidogenesis, what is the phase that follow? So we can see that after acetogenesis is happening. So in the acetogenesis, all the short chain volatile organic acids and all which are formed are getting transferred to the CO2 and hydrogen as well as acetate with the help of this acetogens. So this is happening in the acetogenesis phase. So after that, it is followed by this acetate and this hydrogen and CO2. They are getting converted to the methane gas and CO2 gas with the help of various methanogenic bacteria, or called as here it is mentioned as acetoclastic methanogens. So they convert this acetate and CO2 and hydrogen, and they are getting converted to methane and CO2. So that phase is known as methanogenesis. Hence our answer is acetogenesis, which is option C. So any doubt, anyone? Shall we move on to the next question?
Yes, ma'am.
Okay, thank you. So let us see the next question. So the next question is about which of the following statements are true for anaerobic processes. So there are 3 statements given. Statement 1 is hydrolysis is the first step in anaerobic treatment process. Statement 2 is thermophilic bacteria are most active in anaerobic treatment process. So the statement 3 is anaerobic treatment process consume very less energy. So here options are given. So any answer, anyone? Here 4 options are given.
Option A, ma'am.
1 and 3.
1 and 3, that means option B. Okay. Any other answer?
Two and one, madam.
2 and 1, that means option A. Okay. Any other guess, anyone? Okay, let us see the answer. Yes, option B is the correct answer. Statements 1 and 3 are true. So let us see the detailed solution. It is said that statement 1 is true. Statement 1 is hydrolysis is the first step in anaerobic treatment process, which is true because we just just now only we have seen different steps involved in the treatment process. Hydrolysis means the breaking down of complex molecules into simpler structures or simpler molecules with the help of bacteria. So the hydrolysis is the first and foremost step. So the statement 1 is correct. Then statement 2 means thermophilic bacteria are most active in the anaerobic treatment process. So in the last class or last week 6 lectures, you would have learned about different types of bacteria, thermophilic, mesophilic, and even in this week 7 lectures, there is a discussion about different type of bacteria present in the anaerobic processes. So thermophilic bacteria, they usually they try to exist in a temperature range greater than 70 degrees Celsius or so. So usually in the anaerobic treatment process, the mesophilic bacteria is the most active bacteria. They try to be in the range of around 35 degrees Celsius. In this range they exist. So it is not thermophilic bacteria, but mesophilic bacteria is the bacteria which is most active in the anaerobic treatment process. So statement 2 is incorrect. Then we have the statement 3. Anaerobic treatment process consume very less energy, which is true. That is one of the most important advantage of anaerobic treatment process. They consume very less energy. In fact, anaerobic treatment process produce energy in the form of biogas. So option 3 is statement 3 is also correct. So hence our answer is statement 1 and 3 are true, which is option B. Option B is the correct answer. Any doubt, anyone? Any doubt? Shall we move on to the next question?
Yes, ma'am.
Okay, thank you. So let us see the next question. Next question is which of the following is an anaerobic reactor? It is a pretty straightforward question. So option A is USB, which is upflow. Upflow anaerobic sludge blanket reactor. Option B is sludge digester. Option C is septic tank, and D is all the above. So some of you have mentioned option A. Any other answer?
D, ma'am.
D, all the above. Okay.
D, madam.
C, madam.
C. Okay. So any other answer? So now you have only one option left. Option B, sludge digester. So let us see the answer. The answer is option D, all the above. So let us say one by one. Anaerobic, which of the following is an anaerobic reactor? So USB, as you would have seen in the lecture video, what is USB? USB is the upflow anaerobic sludge blanket reactor that is an anaerobic reactor, that is an anaerobic high rate process reactor. And therefore it is operating in the anaerobic mode, or anaerobic degradation is what is happening inside the reactor. So it is an anaerobic reactor. It is correct. Option B, sludge digester. So sludge digester means I think you have not learned about sludge digestion and all, but sludge digester is a reactor or in which the sewage sludge, like whatever sludge is obtained from the aerobic or anaerobic treatment process, there will be waste sludge produced. So this waste sludge should be treated before discharging into any other metrics like land application or something like that. So this waste sludge has to be treated. So the sludge digester is usually used for digestion of this sludge. So usually as the COD value of or organic content of the sludge would be very high, we always go for anaerobic treatment due to various reasons. One of the reason is the low energy requirement in the anaerobic treatment for treating such a high load of organic matter. So sludge digesters are always or mostly in the anaerobic, operating in the anaerobic condition, or they would be anaerobic reactors. So sludge digester is also correct. Option C is septic tank. Septic tank would be operating in the anaerobic mode only. So it is also an anaerobic reactor. So option C is also correct. Hence our answer is option D, all the above. Any doubt, anyone? If not, let us move on to the next question. Next question is, degradation of organic matter in USB reactor majorly occurs in the option A, sludge blanket zone, option B, setting zone, option C, inlet zone, option D, clarifier zone. So any lead?
Option A, ma'am.
Option A.
Yeah.
Okay. Sludge blanket zone. Any other answer, anyone?
Option C, madam.
Option C. Okay. Any other answer? So let us see the answer. Option A is the correct answer. Sludge blanket zone. You would have learned in the lecture video what are the different zones in a USB reactor. So in a USB reactor, there will be an inlet zone. Then there will be a zone where the sludge blanket is present, where most of the reaction is happening, or where the degradation of organic matter is taking place. So that zone is known as sludge blanket zone. Then there is a zone for settling or clarifying, that is known as clarifier zone. Then there is another zone where this GLSS is present. GLSS means this gas, liquid, solid separator. So that zone is for separation. So these are the zones present in the USB reactor. The question is, degradation of organic matter majorly occurs in. So as we have discussed, most of the reaction or most of the biochemical reaction is happening in the sludge blanket zone. So sludge blanket zone, option A is the correct answer. Any doubt? So let us see.
Okay.
Okay, so let us see the next question. The next question is, the typical structure of GLSS in a circular USB reactor is. GLSS means the gas liquid solid separator. So option A, inclined flat plates, option B, vertical plates, option C, convex disc, option D, inverted funnel. So this is based on the structure of a USB reactor. So any lead, anyone?
D, ma'am.
Option D, inverted funnel. Okay. Any other answer?
D, madam.
Option B. Okay. Any other answer? Let us see the answer. Option D, inverted funnel, is the correct answer. So as while discussing the lecture, you would have heard about the GLSS, which is this gas liquid solid separator, which is present in a upflow anaerobic sludge blanket reactor, USB reactor. So it is usually present at the top of the reactor in the shape of a inverted funnel. So the shape, this shape is given, is designed to the reactor so that there is provision for gas to escape and effluent to get passed. After treating, the supernatant will get passed as the effluent, and it will allow since it is having this slanting structure, all the solids which are reaching the GLSS, they will eventually get settled. They will not escape into the effluent. So this is the reason why it is designed in this inverted funnel shape. So this is about this question. Any doubt? Any doubt?
No. No.
Okay. So let us see the next question. Next question is, which of the following anaerobic treatment process require inert media for operation? Option A, anaerobic fixed filling reactors. Option B, anaerobic filters. Option C, fluidized bed reactors. Option D, all the above. Any answer?
D, ma'am.
Sorry, can you repeat?
D.
D.
All the
All the above. Okay. Any other answer?
Option A, madam.
Option A, madam.
Option A. Okay. Any other layer? So let us see the answer. Option D, all the above is correct. Option A is correct, option B is correct, and option C is correct. So the option these three anaerobic fixed film reactors, anaerobic filters, fluidized bed reactors, they are all high rate reactors in which high efficiency of anaerobic treatment is expected. And this anaerobic fixed film reactors, there will be an inert media in the reactor in which, and the microbes will be attached to the fixed film. So it is an attached growth process reactor. You would have learned about what is this attached growth and suspended growth. In the attached growth, microbes will get there will be inert media or a support structure in which, and the microbes will get attached to the surface, and the wastewater, when it gets when it comes in contact with this inert media, or when it gets passed through the media, microbes which are attached to the inert media, they will act on this wastewater. Biochemical reactions happen, and due to the enzymatic activities and so on, there will be the removal of organic matter. The removal of organic matter will happen, and this is how the reactor works. So that is about attached growth process. In the suspended growth process, there won't be any inert media present. All the microbes will be in the suspended form. There is no place in which the microbes are attached. They are in the suspended form. When they come in contact with the wastewater, due to their activities, the organic matter removal will be happening. So here the question is about the attached growth process, where there is an inert media, and in anaerobic fixed film reactor, it is an attached growth process where the inert media is there on which the microbes are getting attached, and subsequent processes happen. In anaerobic filters also, you would have learned in the lecture that it is an attached growth process. Then in the fluidized bed reactors, in the fluidized bed reactor, there is some media, say fine sand or something, in which the microbes are attached, and when the water is passed, the bed will get expanded or fluidized, and the subsequent processes happen to remove all the organic matter present in the wastewater. So option D, all the above, is the correct answer. Any doubt? Any doubt? Anyone?
No, ma'am.
Okay, so let us see the next question. So next question is, which of the following could be the disadvantage of USB reactor? Option A, high energy requirement. Option B, high aeration requirement. Option C, biogas production.
D.
Option D, high skill and expertise requirement. Okay, option D. Any other lead? Anyone?
D, madam.
Option C, madam.
Option C. Okay. Any other answer? Anyone?
Aeration requirement.
High aeration requirement. Okay. Let us see the answer. Option D, high skill and expertise requirement, is the correct answer. I'll tell you why. We are talking about the USB reactor, which is upflow anaerobic sludge blanket reactor. We are talking about the anaerobic reactor. So first of all, the most important advantage of any anaerobic reactor is their low energy requirement compared to the aerobic process. In the aerobic treatment, energy is required for providing aeration. So in the anaerobic treatment, that much energy is not needed, as there is no aeration provided in the system. Hence, this is a wrong statement. For any anaerobic treatment, the energy requirement is low, not high. So this is wrong. Then option B says high aeration requirement. Anaerobic process is the process in which all the organic matter is converted to methane and carbon dioxide in the absence of oxygen. As the process happen in the absence of oxygen, there is no need for providing any aeration. So this is also a wrong statement. Option B is incorrect. Then we are talking about biogas production. Biogas production, see, in the USB process, all the organic matter is getting converted to methane and carbon dioxide. So the biogas production is an advantage, is one of the important advantage of USB reactor or any anaerobic reactor. It is not a disadvantage. This biogas can be utilized for as an energy source. So it is an advantage, not a disadvantage. Hence option C is also incorrect. Then we are talking about high skill and expertise requirement. So that is a disadvantage of USB reactor, or when it is not only a disadvantage, not only for USB reactor, for any anaerobic treatment system, for any anaerobic treatment of wastewater system, this high skill and expertise is required for the efficient operation of the system. So it is considered as a disadvantage. Like aerobic treatment systems, uh, aerobic treatment system do not require this much high skill or expertise for operation. So this is a disadvantage. Hence option D is correct. Option D, high skill and expertise requirement, is the correct answer for this question. Any doubt? Any doubt, anyone?
No, ma'am.
Okay, so let us see the next question then. So the next question says, which of the following operates only as an upflow reactor? So option A is anaerobic fluidized bed reactor, option B anaerobic contact process, option C anaerobic fixed film reactor, option D sequencing batch reactor. So any guess, anyone? Which of the following operates only as an upflow reactor?
Option D, madam.
Option D, okay. Any other answer, anyone?
A, madam.
Option A, anaerobic fluidized bed reactor. Any other lead, anyone? Any other answer, anyone? Other than option A and D? Let us see the answer then. Option A, anaerobic fluidized bed reactor, is the correct answer. So let us say option B, anaerobic contact process. In anaerobic contact process, the flow can be either upflow or downflow. So only thing is that the wastewater has to be in contact with the microbes. Same is the case with anaerobic fixed film reactor. So in fact, this anaerobic fixed film reactor is mostly operated in the direction of flow, in the downflow direction, to minimize the accumulation of other pollutants. So this you would have learned in the NPTEL this week 7 lecture. So these two processes can be operated either in upflow direction or in the downflow direction. And same is the case with sequencing batch reactor, SBR. However, in the fluidized bed reactor, the main mechanism of operation is the you have the you have the bed media, and the main mechanism is that when the wastewater is getting passed, this bed will get expanded or fluidized, and thus in the process of expansion or fluidization, the contact between the wastewater and microbes happen. Therefore, in order to like for this expansion to happen, it is required that the flow should be in the upflow direction. If it is in the downflow direction, this expansion or fluidization will not take place, as it is governed mainly by the process of gravity and all. The option A is the correct answer, anaerobic fluidized bed reactor. Any doubt, anyone? Any doubt?
No, madam.
Okay, so let us see the next question. So, next question is about the inhibitor. Which of the following are considered as inhibitor in the anaerobic treatment process? Inhibitor means like any material that inhibits or that restricts the anaerobic treatment, or that restricts the action of anaerobic microbes or the efficiency of the process. That is what is meant as inhibitor. So option A is sulfide, option B ammonia, option C heavy metals, option D all the above. So any guess, anyone?
D, madam.
D all the above. C, okay. Any other answer?
Option B, madam.
Option B, okay. So let us see the answer then. Option D, all the above is correct. Option A, B, C, all the three are correct. So this discussion was there in the lecture. There is a discussion on what are the inhibitors in anaerobic treatment process. In that you would have learned about this volatile fatty acid is an inhibitor, then sulfide is an inhibitor, ammonia, and then heavy metals. So all these are inhibitors to anaerobic treatment. So option D is the correct answer. Any doubt? If not, let us see the next question. So next is the second last question. It is a numerical. So it says that there is a USB reactor, and in which 10 mld of wastewater. This USB has the capacity to treat 10 million liters per day of wastewater containing. Sorry, here I have a typo that I will change it in the slides later. Sorry for the error. So containing 5000 milligram per liter of COD, and this USB results in 85% COD removal. Then stoichiometric conversion suggests that 1 kg of COD reduction produces 50 gram of biomass. Determine the amount of sludge produced in the reactor. So you have it is given that Q or flow rate in the reactor is 10 million liters per day, which is 10 into 10 raised to 6 liters per day. Containing COD value is given. COD is 5000 5000 milligram per liter. COD is there in the wastewater. Then the efficiency of the USB reactor in treating the COD is 85%. And stoichiometric conversion suggests that for removing 1 kg of COD, USB reactor produces 50 gram biomass. 1 kg COD, when it is removed, 50 gram biomass is produced. So you are asked to find out, determine the amount of sludge. Sludge means biomass, the amount of biomass produced in the reactor. So this much information is given. So I expect all of you to work on this problem, and then we will discuss the answer. I'll give you about 3 minutes time. Please work on
Madam,
it.
option A.
Option A, okay. So please work out this problem. After that we will discuss the detailed solution.
Option, madam.
Sorry, can you repeat?
Option C, madam.
Option C. Okay.
Option C then.
Option C. Okay. Let us see the answer. Option C is the correct answer. So let us see the answer. Let us see the detailed solution. So here it is said that. So let us see how much determine the amount of sludge produced in the reactor. It should be per day. Okay, per day. So it is given COD is 5000 milligram per liter, which is 5 gram per liter. Total COD per day we have to find out. Per day equal to, here you have to treat 10 into 10 raised to 6 liters. So it will be 10 into 10 raised to 6 liters per day into, for 1 liter it is 5 gram of COD, 5 gram per liter. So it is total COD which is coming into the USB is 50 into 10 raised to 6 gram per day. We can convert it into kg. 50 into 10 raised to 3 kg COD per day. So our USB has to treat this much amount of COD, and it is said that the removal efficiency is 85%. So let us see how much COD is removed. Like only 85% of this much COD will be removed in the USB reactor. So COD removed in USB equal to 85% into this value, kg per day. It is coming around 85 into 5, 25, 42. So this much. COD per day. So this is the amount of COD which will be removed in the system, and it is given that for 1 kg of COD reduction 50 gram biomass is produced. However, we have this much amount of COD. So total biomass produced equal to this much COD is removed into 1 kg produces 50 gram. So this into 50. So it is coming as 425 into 5, 25, 10, 12, 2125, 2125 gram biomass, which is equal to 2125 kg biomass, which is option C. Any doubt, anyone? Is it clear? Is it clear?
Yes, madam.
Okay, so option C is the correct answer. I will explain it once again. Here it is given like you have the flow rate, you have COD, you have, from that you can find out how much COD is reaching the USB reactor. Total COD per day which is reaching the USB is this value Q into this COD 5 gram per liter. It is coming as 50,000 kilogram COD per day, but the efficiency of the USB is only 85%. That means that only 85% of this value will get removed. So the actual COD which is removed in the USB is 0.85 into this 50,000, which is coming as 42,500 kg COD per day. So, and it is given that for every 1 kg of COD reduction happens, 50 gram of biomass is produced. So for 1 kg COD, 50 gram biomass is happening. Therefore, for 42,500 kg COD, 42,500 into 50 gram of biomass will be produced, which is coming as 2125,000, which is 21,25,000 gram biomass will be produced, which is around 2125 kg biomass, and it is option C. So option C is the correct answer. Is it clear?
Yes, ma'am.
Okay, so let us move on to the last question for today's session. That is also a numerical. So the last question is, in the process of methanogenesis, so the question is about the methane production. Acetic acid gets converted to methane and carbon dioxide as per the reaction. CH3COOH gives methane plus carbon dioxide. Considering 80% conversion efficiency, methane gas in meter cube produced in a reactor fed with 10 mld wastewater having 180 milligram per liter acetic acid would be approximately. So I will explain what all things are given. So it is given that the reaction is given CH3COH. Acetic acid is converted to methane plus carbon dioxide in the process of methanogenesis, and it is said that the flow rate into the reactor is 10 mld, 10 million liters per day, and the methane gas produced in a reactor fed with 10 mld having 180 milligram per liter of acetic acid. So in the wastewater which is coming into the reactor, the organic matter present is in the form of acetic acid, which is the concentration of acetic acid is 180 milligram per liter. So for every 1 liter of wastewater, 180 milligram of acetic acid is there, and it is also given that the efficiency, this efficiency like of methane production, efficiency of conversion is 80%. So you have to find out the amount of methane gas produced in meter cube. So I expect all of you to work on this problem and say the answer. So any answer, anyone? Or I will give you some 3 minutes time. So these many parameters are given, and even the density of methane is given. Density is equal to 465 kilogram per meter cube. Is there anyone who is working on this problem? Otherwise we shall discuss the solution. Should we wait or proceed?
Proceed, madam.
Okay, so let us see the solution. So first of all, let us see the equation. So the conversion equation is that the CH3COH is getting converted to methane and carbon dioxide. So the CH3COH, the molecular weight is carbon 12 into 2, 24, plus 4 hydrogen is there, therefore 4, plus oxygen 16 into 2, 32, therefore 60. So 60 gram of acetic acid is converted to, here you have 12 plus 4, 16 gram methane. Similarly, 60 kg acetic acid in normal case will get converted to 16 kg of methane. So that is what we know. However, so usually 1 kg of acetic acid, when it is treated, it will be 16 by 60 kg methane. However, conversion efficiency is given as 80%. Therefore, the entire 1 kg, we expect this 16 by 60 kg of methane. However, in actual case, 1 kg of acetic acid will be converted to 0.8 into 16 by 60, which is coming as 8 into 16 by 600, which is coming to be about, we calculate in the calculator, 8 into 16 divided by 600, 0.213. It is coming as 0.213 kg methane. So this much information we know. 1 kg of this acetic acid will be converted to 0.213 kg methane. Then we have the information that we have the flow rate as 10 million liters per day and concentration as 180 milligram per liter. So total amount of this acetic acid coming to the reactor equals 10 into 10 raised to 6 liters per day into 180 milligram per liter. That is coming as 1800 into 10 raised to 6 milligram of acetic acid, which is about 1800 into 10 raised to 6 milligram means 1800 kilogram acetic acid per day. This much is coming into the system. So we know the conversion that for 1 kg of acetic acid, 0.213 kg methane will be produced. We have 1800 kg acetic acid. Now we will know how much kg of methane will be produced. So therefore 1800 into 0.213 equal to into 1800. It is about 384 kg methane per day. So now we know the quantity of methane in terms of kg. However, it is asked to find out the methane gas produced in meter cube. So for that, the density of methane is given 465 kg of methane per meter cube. So now, in order to get the methane in meter cube, you have to divide by density. It is equal to 384 by 465. It is let us write the units also. 385 kg per day. Here you have kg per meter cube. Kg and kg we have to find out what is 384 by 465. It is coming as 0.83 meter cube per day. So option A, 0.83 meter cube is the correct answer. Any doubt, anyone? Any doubt? Is it clear?
Can I explain once again, madam?
Yes, I will explain it once again. So see this problem, it is given that this acetic acid is getting converted to methane and carbon dioxide. So, and it is also given that there is 180 milligram per liter of acetic acid in the wastewater. And based on this equation, we know that you have to find out the molecular weight. Based on the molecular weight, the 60 gram of acetic acid is converted to 16 gram of methane. Therefore, when you convert it both the sides, LHS and RHS, into kilogram, it is 60 gram, 60 kg is getting converted to 16 kg. Is it clear?
Yes, madam.
Yes. So, therefore, 1 kg of acetic acid will be converted to 16 by 60 kg of methane. Am I right?
Yes, madam.
Yes. There, but in the question it is given that only 8, there is the conversion efficiency is only 80%. That means that the entire 1 kg, when the methane is produced, the 16 by 60, this much amount won't be produced. Only 80% of this value will be produced. Therefore, the actual amount of methane produced from 1 kg of acetic acid is 0.8 into 16 by 60. Is it clear?
Yes, madam.
Therefore, by doing this calculation, you get it as 0.213 kg methane. Is it clear?
Yes, madam.
It is simply 0.8 into 16 by 60. It's clear, right? So,
Correct.
we have 1 kg. We know that 1 kg of acetic acid produces 0.213 kg of methane. Now we have quantity of wastewater. The total quantity of wastewater coming into the reactor is 10 million liters per day, which is 10 into 10 raised to 6 liters per day. And we know that the amount of acetic acid present in the wastewater is 180 milligram per liter. From these two information, we will get to know what is the actual quantity of acetic acid which is coming into the reactor per day, right? By multiplying these two, we will get this. Uh, we will get it as 1,800 kilogram acetic acid is there in the anaerobic treatment process per day. Is it clear?
Yes, madam.
Yeah. So now we know that the amount of acetic acid is 1,800 kilogram. We know that 1 kg of acetic acid produces 0.213 kg of methane. And we know the quantity of acetic acid, which is 1800 kg. Therefore, the amount of methane produced you can find out, right? 1800 into 0.213. Is it clear?
Yes, madam.
Okay, so while calculating this, you get it as 384 kilogram methane per day. However, as it is a gas, we do not express in terms of kg. We always express in terms of volume only. That is, in the question it is asked to find out the methane gas produced in meter cube. For that purpose, density of methane is given. We know the mass, we know the density. Now we can find out the volume, right? Density is equal to mass by volume. Volume is equal to mass by density. Is it clear?
Yes, madam.
So, here the mass is 384, volume is 465. So, density is 465. So, mass by density gives the volume, which is coming as 0.883 meter cube. Is it clear?
Okay, madam. Okay.
Okay. Any
Thank you,
other
madam.
doubt? Thank you for your question. So, any other doubt, anyone? Any doubt, anyone? So I hope there is no doubt other than this. So with that, let us close this session. Before that, in the last class, some of you have asked about the MLVSS and sludge volume index.
Yeah,
Who has asked?
yeah, ma'am. I was the one who asked actually.
Okay. I have to tell you that this sludge volume index and MLSS or MLVSS, whatever it is, there is no such relation between them, because it is that you have asked that your MLSS is increasing but your sludge volume index is not changing. With this,
Not changing.
sludge volume index is a measure of the quality of your sludge. It gives you the information regarding how good is your sludge. Like if the sludge volume index is more, it means that there is a lot of bulking in the sludge and the quality of sludge has got deteriorated. uh, you for the for the calculation of sludge volume index, what you are doing is that you are taking 1 gram of sludge and making it to settle, right?
Yes, ma'am. I'm taking 1 liter of this thing sludge and making it settle. Correct.
Actually, the according to the definition, you have to take 1 gram of sludge and make it into settle. So anyway, whatever the MLSS concentration is, you are taking only 1 gram of it, 1 gram of it, and making it into sludge, making it into settle. Hence,
Yeah.
the quantity, the value of MLSS is in no way related to your SVI. Is it clear?
Okay, fine. And because of the formula, I got confused because
Yeah.
SBI was MLSS into this thing. But I thought there's a
But
relationship.
yeah, it is according to the theory. You are just measuring the settling characteristics. You are taking, suppose your MLSS in this month is about 1000 milligram per liter, and then the next month it is 2000 milligram per liter, but you are taking the 1 gram out of it uh, to settle.
Okay, fine.
Yeah,
Yeah, I get it now. Okay,
so that is why it is not getting affected.
okay, fine. Thank you.
Okay. So thank you for your question. So there is no other doubt. Shall we close the session?
Yeah. And one more thing about the today's reactor when we discussed that
Yes.
that SBR won't have upflow reaction, ma'am.
It won't have upflow reaction, but see, like in SBR system, it is a sequential batch reactor, right?
Ma'am, that is sorry to interrupt because we are working in a technology where we have provided upflow for an SBR actually
Okay, but the question was that
for anaerobic. Yes.
no, the question was that in which of the reactor the upflow or the down only upflow mode can be operated, but in SBR both the modes can be operated.
Ah,
Downflow is
fine.
also
Okay,
possible.
correct.
Yeah, that is
Yeah,
why
ma'am.
it is not an option.
Okay, thank you.
Okay, thank you for your question. So any other doubt, anyone? If not, shall we close the session?
Yeah, ma'am.
Okay, next class is on next Tuesday, same time. Thank you.
Okay, madam. Thank you.